All right, welcome back to the Institute. In today's lecture, I'm basically going to talk about two things: the beta functions. Then when we are done with that, I'll give you final tips for our end of semester examination towards advanced calculus 2. Okay, so in the beta function, our main objectives are: one, by the end of the lesson, we should be able to define the beta function using the integral form, right? And then two, we have to be able to understand its symmetry property, okay? Then three, we need to be able to connect the beta to the gamma function, okay? The relationship. And then four, we have to be able to evaluate integrals using the beta gamma relationship. And finally, we have to be able to solve problems involving both beta and gamma functions. Okay, so let's get into the video. Okay, so we are going to begin with the introduction to beta functions. All right, so first of all, look at the definition. All right, so one thing is you have to know that for m, you have to know that m is greater than 0, n is also greater than 0. So that is the definition. M and n, they are positive. M and n, they are positive. Right, so the beta function is defined as from in beta of m comma n is equal to, right? So once m and n are positive, that is greater than 0, then you have to know that it is defined over this integral from 0 to 1 of t to the power m minus 1 into 1 minus t to the power n minus 1 e to the power, right? So this is the definition for beta. All right, so that is the definition for beta. Next, this thing we see right here is known as the Euler's first kind, right? The Euler's integral of the first kind. So this is known as the Euler's integral of the first kind. So you have to know that the Euler's, this is known as the Euler's integral of the first kind. Okay, so I believe most of us knows about Euler's, right? He's a great mathematician. Full name is Leonhard Euler, right? So in another time, we will talk about Euler's lifespan and what he did to the world of mathematics. All right, so next we have to look at the symmetry property. So basically, if you have beta of m and n, then it's simply the same as beta of n comma m. So this is the symmetry property. All right, so the position of m and n doesn't affect your results. However you position it, it must give you the same result. So that is the symmetry property. So The proof of change of variable is also there, where you will let u equals 1 minus t, okay, in the integral. That is also there. Now let's look at the connection between the gamma and the beta, right? The connection with the gamma to the beta function. So let's look at the definition of the gamma function, right? So the definition of, this is the symbol for gamma, right? Uppercase gamma function, right? So this is the definition. All right, this is the symbol for gamma. All right, so the definition is gamma of z is equal to integral from 0 to infinity t to the power z minus 1 e to the power negative t dt. All right, so this is the definition for gamma. All right, one thing you have to know is that z is a positive value, right? So z, note, z is greater than 0. Z is greater than 0. So if you have z that is not greater than 0, you have to make sure that it becomes, or it is greater than 0, right? So now let's look at the key identity that is connecting beta and gamma, right? So the key identity that connects beta and gamma is beta of m comma n is equal to gamma of m times gamma of n divided by gamma of m plus n, right? So this is the association between beta and gamma. This is the association between beta and gamma. All right, there is a proof for this. We will look at the proof, then we'll look at another proof, of which is another formula, right? So we look at the proof for this. When we are done, we look at the proof for the other formula. Then we start solving problems and talk about some tips. Okay, so let's look at the proof. Let's look at the proof. So proof. Let's look at the proof. All right, we are looking at the proof for this particular one, right? So step one, we say that gamma of m dot gamma of n is equal to 0 to infinity of this particular function, t to the power z minus 1 e to the power negative t dt, times 0 to infinity s to the power n minus 1. So let's use m here, right? N minus 1 e to the power negative x dx, right? So this is basically, this is a double integral. This is a double integral over the limit 0 to infinity to 0 and also 0 towards infinity. Okay, so this is a double integral over the limit 0 to infinity times 0 towards infinity. Okay, so we are going to let some variables represent some variables so that we can deal with it very easily, right? So we are going to say that I won't clean this, right? Because this is what we are trying to prove. Okay, so let's say that T should be equal to, T from here should be equal to RU. And also, let's say that S from here should be equal to R of 1 minus U. And then we say that R should belong to 0 to infinity, and also U should belong to what? 0 to positive 1, right? So if that is the case, then we can say that, the T, the S is equal to R the R, the U, right? The T, the S will be equal to R the R, the U. Okay, so since we have changed all the variables from T and X, we have to also change their respective variables. Okay, so the next thing we are going to say is that we have to transform this particular integral, right? So we are going to transform this particular integral to have gamma of m times gamma of n equals, right? And that will be equal to from 0 to 1 of u to the power m minus 1, right? That is what we've defined here. We said that u should be what? 0 to 1 of this. Okay, so times 1 minus u to the power n minus 1 du times 0 to infinity of, now we said that s should be equal to what? R into what? 1 minus what? U. But we have been able to do that substitution in there, right? So we're going to say that R to the power m plus n minus 1 times, now we're going to have e to the power negative r, the r, right? Because we said that s should be equal to what? R into 1 minus what? U. So we have that substitution in here. So this is the transformation of this integral to this form. So clearly we can say that this right here is that great. So we can say that gamma of m dot gamma of n is equal to, this is a double integral, right? So this is u to the power m minus 1 times 1 minus what? U all to the power n minus 1. And this is indices, right? If you work on this very well, you're going to have beta, oh come on, you're going to have beta of m comma n times gamma of m times gamma of m plus n times gamma of m plus n, right? Yes, plus gamma of m plus n. So basically we can say that if this is equal to this, then if you are interested in this, you just divide through by what? Gamma of m plus n, right? So we say that beta of m comma n is equal to gamma of m times gamma of n divided by gamma of m plus n, right? So we can say that we have truly proven this particular identity. All right, so that is the proof for this particular identity. Now, once we have been able to prove this particular definition, I want us to prove another one, of which is going to help us a lot in our daily problems with beta and gamma relationship issue, right? So give me some short minutes, reflect on this particular proof. I'll be right back with that particular formula as well. All right, I'll be right back. All right, welcome back from the short break. I believe that you have been able to go through the proof of that particular formula and you are really okay with that. Now, let's look at this particular identity. We are coming to prove this particular identity. Once we are done with it, then we will tackle problems that are likely to drop in the exams. Right, so let's look at how we can prove this identity. Now, one thing you have to know about this identity is that it's basically a standard trigonometric identity, right? It's a standard trigonometric identity. Anyway, trigonometric integral transformation is a standard trigonometric integral transformation, okay? Now, let's look at how we can prove it. So step one, we have to let some variable, okay? So let's say that I is equal to the whole of this function, right? I, which is integration, is equal to this integrand, right? So let's I equals this. So integral from 0 to 1 of sine 2m minus 1 theta cos 2n minus 1 theta d theta, right? So once we have this right here, our main objective or our main goal is to express this particular one as, or in the form, our main goal is to express this one in the form beta of m comma n equals integral from 0 to infinity, 0 to pi on 2 of t to the power m minus 1 into 1 minus t to the power n minus 1 dt. So this is our main focus, right? So we want to express this in this form, okay? So what we are going to do is that we have to let some variables represent some variables, okay? So that, or basically we are going to do what we call substitution, right? So that we can do this proof. All right, so let's say that t is equal to sine squared t, right? So here, okay, t is equal to sine squared t, and so if t is equal to sine squared t, then we can say that sine theta is equal to square root of t. We take square root on both sides, and this will cancel the square root side, right? And also, let's say that, so if this is equal to this, and we take square root on both sides, we have sine theta is equal to square root of t, then it means that we are going to have theta to be in the range of 0 to pi on 2, right? So this will be the interval for what? Pi, right? So now let's also say that this right here, right, cos theta should be equal to cos theta should be equal to cos squared theta should be equal to so that will be square root of 1 minus t, right? So that will be square root of what? 1 minus t for cos theta. Okay, so once we have these definitions, then we can also say that the theta should be equal to this the theta, right? This the theta should be equal to what we have right here, r 2 sine theta cos theta the theta, right? So we made t to represent sine squared theta, and we made 1 minus t to represent what? Cos squared theta. So it means that cos theta, if you take the square root on both sides, you're going to have what? Cos theta to be what? Square root of 1 minus t. And so the t will be equal to what? 2 sine theta cos theta d theta. Okay, so once we know this, then the next thing we have to say is that we have to make sure that we make the theta the subject, because we will do substitution. We are actually doing substitution work here. So if we do that, we're going to have the theta equals the t divided by 2 sine theta cos theta, right? So this is the substitution that we are going to do. So wherever we will be seeing the theta in this here, we will replace it with this. And then wherever we see cos, we will replace it with this. Wherever we see sine theta, we replace it with what? Square root of what? T. Right. So let's first express the integral. Okay, let's first express the integral in terms of what? T, because we have changed everything from what? Theta to what? T. So let's first do that expression before we move on. Okay, so we're going to say that I should be equal to integral from 0 to pi on 2, right? Sine 2m minus 1 theta cos 2n minus 1 theta, the theta will be equal to 0 to 1, into t to the power m minus half times 1 minus t to the power n minus half, right? Times, now our d theta is dt over 2 sine theta cos theta, right? So we actually did indices in here. Indices says that, this is sine squared 2m minus 1. Basically, is equal to sine 2m divided by sine, right? And since they are having the same base, they subtracted the exponent, right? So that's why they were having sine 2m minus 1. So if that is the case, then it means that when we represent it with square root of t, it will change it to what? Half, right? So that is what we have in there. Okay, so the next thing we have to do is to simplify this, right? So we have to simplify this. And so from here, we're going to say that this right here, t to the power m minus half divided by square root of t should be equal to, you know that sine theta is what? Square root of t. So we have replaced, okay, let me do that substitution before we do this. So we know that this to the power m minus half times 1 minus t to the power n minus half, the t divided by 2 times sine theta is square root of t, right? So square root of t times cos theta is square root of 1 minus t. So we have times square root of 1 minus what? T. So it means that each of these terms, right, are divided by these expressions or these arguments, right? So we're going to say that let's simplify them term by term. Okay, so let's simplify this and this first. So we're going to have t to the power m minus half divided by square root of what? T. And that will be equal to, you know, this is square root 2. So when we express the square root as half, we're going to have t to the power m minus half divided by 2 t to the power half, right? So, and this is equal to, since the bases are the same and they are dividing, we subtract the exponents, right? So we are going to have t to the power m minus half minus t to the power half, right? So minus half becomes what? Minus 1. So you're going to have t to the power minus 1, right? So we have obtained this with this to be what? T to the power m minus 1. That is so simple, right? Now, let's consider this and this, right? This and this. Okay, so I don't want to clean this because we are proving to see if we will get this, right? So, okay, let me clean this, right? Okay, so now we consider this to simplify. So we have 1 minus t to the power n minus half divided by square root of 1 minus t, right? So that will be equal to, this is basically equal to 1 minus t to the power n minus half divided by 1 minus t to the power half. The bases are the same and they are dividing, so we subtract the exponents, right? So we have 1 minus t to the power n minus half, right? So this will be equal to 1 minus t to the power n to the power what? Minus 1. So this has been done. So interesting, right? So we have been able to get the first component and the second component. So what we have to do is to substitute into this, right? Okay, so we can say that I is equal to a half of, remember there is a half here, so we factor that half out. This is 1 over what? 2. So we factor that out and we have half of integral from 0 to 1 of, now this and that is this, right? So we have t to the power m minus 1, and also this and this is what? 1 minus t to the power n minus what? 1. All right, or the t. So this is what we have. Okay, now we have been able to express the I, which is the integration, in the form half of integral from 0 to 1 of t to the power n minus 1 times 1 minus t to the power n minus 1 dt. And this is actually the final answer. We know that this is equal to what? Half into bracket, half times what? Beta into bracket what? M comma n. This right here is equal to that. So we're going to say that I is equal to what? Beta into half of what? Beta into what? M comma n. And that is equal to what? Half from 0 to 1 t to the power n minus 1 times 1 minus t to the power n minus 1 dt. So eventually we have been able to what? Prove the expression. And this basically satisfies this. Since this is equal to this, and we are having half of beta into m comma n is equal to this, that means that this is equal to that. That is interesting. So we're going to say that this is equal to that. Okay, so let's conclude here so that we start solving problems. Okay, so that's the final result. The final result becomes half of beta into m comma n is equal to from 0 to what? From 0 to what? Pi on 2, right? Because we said this is equal to that. So now we are going to use that. Pi on 2 of sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta the theta, right? So it means that wherever we see this expression, this half beta of these two parameters is equal to this, right? So we have actually proven the identity, right? And this identity is going to help us a lot in our daily dealings with beta and gamma association. Okay, so that is the proof for the identity. Now, we are going to start with problems that are likely to come into the exams. Okay, give me some few minutes. I'll be right back with problem number 1. Okay, so welcome back from the short break. Now, I believe you have been able to reflect on the proof of the identity and you're good with it. Now, the first problem is we want to evaluate this particular beta of these two parameters, right? So beta of 1 on 4, comma 3 on 4. Okay, and we have been hinted that gamma of x times gamma of 1 minus x is equal to what? X over what? Sine pi x. And x ranges between 0 and what? 1 inclusive. So first of all, we have to look at this problem and decide the kind of formula we are going to use, right? Either we are going to use the definition that we proved earlier, or we are going to use the identity that we just proved. So with this particular problem, we are basically going to use the definition, right? Because we don't have any integral symbol in here. So we are going to use the definition where we have the beta gamma relationship. Okay, so first of all, we know that we have been given beta of 1 on 4, 3 on 4, right? And as usual, the beta gamma association, we know that this is equal to, so actually we know that beta of m comma n is equal to gamma of m dot gamma of what? N divided by gamma of m plus n. Right, so we know this association, right? This is the association that we know. Now, we know that the first parameter is for m, the second parameter is for n. And we know that their symmetry, you can change the position and it will not affect your result, right? Okay, so we know that this will be equal to beta of 1 on 4, 3 on 4 will be equal to gamma of 1 on 4 times gamma of 3 on 4 divided by gamma of 1 on 4 plus gamma of 3 on 4. Right, so we're going to say that this right here, let's remain it for now and simplify the denominator, right? So divided by 1 over 4 plus 3 over 4 is basically 4 over 4, right? So we're going to have gamma of what? 4 over 4. And this is equal to gamma of 1 on 4 times gamma of 3 on 4 divided by gamma of what? 1. And remember from gamma, the foundation of gamma lesson that I took you through the last time, we realized that gamma of 1 is the same as 0 factorial, right? Because if you have gamma of an integer, if you want to know the value, you just take 1 from the value. When you are using the factorial association, right? So gamma of 1 is equal to 1 minus 1 factorial, right? And this is equal to 0 factorial. And we know that 0 factorial is 1, right? So the denominator tends to what? 1. So we're going to say that we have gamma of 1 on 4 times gamma of 3 on 4 divided by 1. And this is equal to gamma of 1 on 4 times gamma of 3 on 4. Right, so now this is what we have. We can still do something about this. But the question says that we should evaluate this, right? And we have been hinted. If not, like we'll go straight and give the final answer. But we have been hinted that gamma of x dot gamma of 1 minus s is equal to x over sine pi x. So we have to be able to divide, identify our x in here. Okay, so our x in here is the first parameter, which is what? 1 over 4. So our x in here, x is equal to 1 over 4, right? Once once we have identified our s, then we have to go back to the question and remember that gamma of x times gamma of 1 minus x is equal to x over sine pi x, right? And we have to be able to simplify this first, right? So we know that gamma of 1 on 4 times gamma of 1 minus 1 on 4 will be equal to x over sine pi x, right? So we have to simplify this. So we know that gamma of 1 on 4 times gamma of 1 minus 1 on 4 is 3 on what? 4. So we're going to have 3 on 4 equals x over sine pi x. And we know that gamma of 3 on 4 is pi, right? So we're going to substitute there. So we have pi divided by sine pi times, now our x, we know that our x is what? 1 on 4. So we have 1 on 4, right? So we're going to have pi divided by sine pi divided by 4 is 45, right? You know, pi is 180, right? So we have pi on 4 equals pi over sine 45. And sine 45 is square root of 2 over 2. So we have pi over square root of 2 over 2. Okay, so this, when we simplify it, then we are going to have pi divided by square root of 2 on 2 will be equal to pi times 2 over square root of what? 2. And this is equal to 2 pi divided by square root of 2. And this, if you rationalize this, you're going to have 2 pi times square root of pi times square root of 2 divided by what? 2. And this here, this cancels this. So you have square root of 2 pi, right? So this becomes our final answer to this particular problem. Square root of 2 pi. Square root of 2 pi. Okay, so one thing we have to know is that if you have the problem in this nature, then you have to remember the definition, which is beta of m comma n is equal to what? Gamma of m times gamma of n divided by gamma of m plus what? N. If there is no hint, then you go straight forward and provide your final answer. But if there is a hint, you have to follow the hint and deal with your problem. So that is question number 1. Now let's look at question number 2. All right, I'll be right back with question number 2. All right, welcome back from the short break. I believe you have been able to reflect on the first question and you've really understood it very well. Now, let's look at this particular problem, which is question number 2. We want to evaluate this particular integral, right? And it's from 0 to what? Pi on 2. So quickly, we have to remember the formula that relates integral with what? Beta, right? So we know that we have a certain formula which is beta of m comma n divided by what? 2. And that is equal to gamma from 0 to what? Pi on 2 of sine 2m minus 1 theta cos 2n minus 1 theta the theta, right? So we are going to use this association or this relationship between beta and integral. Okay, so we are just going to compare, all right? We are going to compare this to this, okay? So in here, we are going to compare this to this, then we find the value of m and n respectively. Then we substitute into this to evaluate. And remember, this right here has an association with gamma. Beta has an association with gamma. So once we are done identifying m and n, we have to remember the association between gamma and beta. Okay, so from here, we know that we have 2m minus 1 to be equal to, when you compare this with this, you can see that the exponent here will be equal to this. So we have 3 here, and that we have 2m to be equal to 3 plus 1, right? So we have 2m to be equal to 4, and that's m will be equal to what? 2, right? And also we compare this to this, right? So we have 2n minus 1 to be equal to 5 on 2, right? So 2n to be equal to 5 on 2 plus 1, right? So basically, we're going to have 2n to be equal to 5 on 2 plus 1 is basically 7 on 2. So we're going to have 7 on 2 here. Divide here by 2, divide here by 2. We have n to be equal to 7 on 4. Right. So once we have been able to identify your m and the n, substitute into this. Then you relate it to the relationship between gamma and what? Beta. So we're going to have beta of 2,7 on 4 divided by 2 should be equal to gamma of m times gamma of what? N divided by gamma of m plus n. Right. So in here, what we have to do is to send this here instead, right? So we're going to have beta of 2,7 on 4 to be equal to half of gamma of 2 times gamma of 7 on 4 divided by gamma of 2 plus 7 on 4 right here. So basically, we are going to have, remember that from the gamma lesson, we learned that gamma of 2 is equal to what? 1. Because gamma of 2 in relation to factorial is what? 2 minus 1 factorial. And we know that 2 minus 1 factorial is what? 1 factorial. And 1 factorial is what? 1. So gamma of 2 is equal to 2 minus 1 factorial, and that is equal to 1 factorial, which is equal to what? 1. So we have been able to identify what? Gamma of what? 2. Now let's simplify the denominator. We know that gamma of 2 is what? 1 times 7, gamma of 7 on 4 divided by 7 on 4 plus 2 is basically 4 on 2, right? That will give you 2. So that would be 11 on 4, right? So that would be 11 on 4. Yes, that would be 11 on 4. Yes, that would be 11 on 4. No, 15 on 4 instead. Sorry. So we have gamma of 15 on 4, right? So we are going to now simplify this. So what do we have to do? This here we know that gamma of 7 on 4, we cannot determine its value straightforward because it is not an integer, right? So we have to use the idea that gamma of 7 on 4 is basically equal to gamma of 7 on 4 is basically, okay, so gamma of, let's deal with the denominator first. Gamma of 15 on 4 is equal to 11 over 2 times 11 over 2 times 7 over 4 times gamma of 7 on 4, right? We know that gamma of 7 on 4 is basically 1, right? Gamma of 7 on 4 is basically 1. So we're going to have 77 divided by 4 times 4 is basically 16. So you're going to have 16 here. So gamma of 7 on 4 is 1. So note that gamma of 7 on 4 is basically 1. So in all, we are going to have half into 1 times 1 divided by 77 divided by 16, right? So we're going to have half into this. When you reciprocate this, you're going to have 16 over what? 77, right? And this will give us 8 over, because this will cancel this 2, right? 8 times. So we have 8 over what? 77. 8 over 77. Okay, so that is basically the final answer to this particular problem. 8 over 77. So this gave us 8 over 77. 8 over 77. So please, you have to know the relationship between gamma and beta, and you are good to go with every problem. Now, give me some short minutes. I'll be right back with question number 3. Welcome back from the short break. I believe that you have been able to reflect on the question number 2 and you're good to it. Okay. So welcome back from the short break. I believe that you have been able to reflect on the question number 2 and you're good with it. So now let's look at question number 3. So we want to evaluate this integral, right? 0 to pi on 2 sine to the power 10 theta the theta, right? So remember, if not beta gamma relationship, if not Euler's idea to develop this formula for us, then we are going to use reduction formula for this, which is kind of difficult, right? But in here, we are going to use the beta gamma relationship. So recall that 0 to pi of sine 2m minus 1 theta cos 2n minus 1 theta the theta is equal to half of beta into m comma n, right? So we are going to use this relationship to solve this problem. And we know that when you compare this to this, it means that 2m minus 1 is equal to what? 10, right? So we have 2m equals 11. So it means that m is equal to 11 on what? 2, right? Here we have 2n minus 1, 2n minus 1. But when we compare it here, we don't have any term for what? cos, right? So it means that we have 0. So this will be equal to what? 0. So we have 2n equals what? 1. So it means that n is what? Half. So if we have m and we have n, then we can go ahead and use the relationship between beta and what? Gamma. So we know that beta of m comma n will be equal to half of what? Gamma into m dot gamma into what? N, divided by gamma of m plus n, right? So we know our m and we know our n. So we're going to have beta of 11 on 2 comma half equals half into gamma of 11 on 2 times gamma of 11 1 on 2 divided by gamma of 11 on 2 plus 1 on 2. Here, we know that gamma of half is what? Square root of pi. Okay, so the only thing we have to do is to simplify what? Gamma of 11 on 2. And recall that gamma of 11 on 2 is 9 on 2 times 7 on 2 times 5 on 2 times 3 on 2 times what? Square root of what? Half. So we're going to have 11, gamma of 11 on 2 as 9 on 2 times 7 on 2 times 5 on 2 times 3 on 2 times square root of half, right? Gamma of half, sorry. Gamma of half times the last part, which is gamma of half. We know that it is square root of pi. So we're going to have, okay, let's maintain that for now, divided by gamma of 11 on 2 plus half, it's gamma of what? 12 on what? 2. So we have gamma of 12 on 2, right? So this now drops down to half into 9 on 2 times 7 on 2 times 5 on 2 times 3 on 2 times gamma of half is square root of pi. So we have square root of pi times square root of pi divided by gamma of 6, right? Gamma of 6, right? Now, remember that gamma of 6, you have to set it to the factorial form before we can factorize it. So gamma of 6 is the same as 6 minus 1 factorial, which is what? 5 factorial. And we know that 5 factorial is what? 5 factorial is basically 120, right? So when you multiply everything here, we are going to have half into 945 times square root of pi times square root of pi becomes what? Pi, divided by gamma of 6. We know that is the same as 6 minus 1 factorial, of which is going to give us 5 factorial, and 5 factorial is 120. So we have 120 here. So we multiply through by half, and we're going to have 945 pi 945 pi. Okay. Now remember that these things are divided by 2. So 945 divided by 32, right? So 945 pi divided by 32 divided by 120, right? Or half. And this boils down to half into 63 divided by 256 or pi, right? And this, when you simplify it, well, you're going to have 63 divided by 512 pi. 63 divided by 512 pi. So that is the result for this particular problem. Okay, so this, you have 63 divided by 512 pi. Okay, 63 divided by 512 pi. Okay, so that is the answer for this particular problem number 3. Now let's move on to problem number 4. And that is actually a question that is going to come, believe me. So stay tuned. I'll be right back with question number 4. So welcome back from the short break. I believe that you have been able to reflect on that particular problem and you are good with it. Now let's look at example number 4. All right. And this example, trust me, is going to come. So take note of it. So with this particular problem, we want to evaluate this. Okay, so we have to use the beta function. Okay, so we know that half beta of m comma n is equal to integral from 0 to pi on 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta, right? So when we compare, we have 2m minus 1 equals 6. So this means that 2m equals 6 plus 1. This implies that our m is what? 7 on 2, right? So we have our m. So we have to look for our n as well. And looking at the problem that we have been given, we don't have any cos term. So it means that that section is what? 0. So we have 0 equals this, which is 2n minus 1. So we have n to be what? Half, right? So we have the value of m and the value of n. So we just have to use the beta gamma relationship. So we're going to have beta of 7 on 2 comma half equals half into gamma of 7 on 2 times gamma of half divided by gamma of 7 on 2 plus what? Half, right? So we're going to have half into gamma of 7 on 2 times gamma of half divided by gamma of 7 on 2 plus half is basically 8 on what? 2, right? So we have gamma of 8 on 2, right? So this is equal to half into gamma of 7 on 2 times gamma of half divided by gamma of what? 4. We know that gamma of 4 is equal to what? 4 minus 1 factorial, which is what? 3 factorial. And 3 factorial is what? 6. So we have the denominator simplified. We have to simplify the numerator as well. Then we are good to go. So from here, we know that gamma of 7, okay, so we have the denominator, and we know that gamma of half is equal to what? Square root of what? Pi, right? So we are left with gamma of what? 7 on 2. And what you have to know is that gamma of 7 on 2 is gamma of 7 on 2 is equal to 5 on 2 times 3 on 2 times half times square root times gamma of what? Half, right? So we're going to have that to be equal to 15 over 4 times what? Square root of pi. So we're going to have 15 over 4 times square root of what? Pi, as the result for what? Gamma of what? 7 on 2. So now we have the result for 7, gamma of 7 on 2, and then we have the result for gamma of what? Half, which is what? Square root of what? Pi. So we just have to substitute and simplify, then we are good to go. So from here, we're going to say that we have 15 times square root of pi times this square root of pi divided by 4 or divided by 6, right? Remember that there is a half, so all this thing times half, right? So we're going to have half into this right here is going to be 15 pi divided by 4 or divided by what? 6, right? So when you do this, you know that we are going to have so we're going to have half into 15 pi divided by, this is going to give us, everything is going to give us 48, right? So 15 pi divided by what? 48. And this right here, we have to multiply it by what? Half, right? We have to multiply this thing by what? Half, because this one is the result for this. So the half over here has to be multiplied with this. So we have times half. So we have what? 5 divided by what? 32 pi. 5 divided by 32 pi. And that is the answer for this particular problem. 5 over 32 pi. 5 over 32 pi. So that is the question that we were given in the tutorial section. And I believe that this particular question will come. And the answer is 5 over 32 pi. 5 over 32 pi. So now, let's move on to the question number 5. With that, it is actually a special case, right? So with question number 5, it's actually a special case, and you have to know it, because if it comes, you don't need to work it out, right? So we know that gamma beta of m comma n is equal to beta of n comma m, right? That is symmetry, right? What I'm coming to give it to you right now is a special case. So we know that if m is equal to n and they are equal to half, then if you compute the result for beta of half comma half, you are going to have square root of pi. You are going to have square root of pi. And that is actually a special case. That is actually a special case, because with this, if you try to use the approach to work it out, you'll not get this answer. You'll be getting pi. But this is a special case, and you have to note it. This is a special case, you have to note it. So beta of half comma half is square root of pi. Square root of pi. So these are the few things you have to know for the exams that is coming up on Tuesday. Now, I want to give you 2 trials, right? I will give you 2 trials for your own rehearsals. But one trial, you have to take note of it because with that too, it will come to the exams. So give me some short minutes. I'll be right back with those trials. Okay, so welcome back from the short break. I believe you have been able to go through the solution for the previous ones and you're good with them. Now, these are your trials. Please do well to go through them and get the answer because they are likely to drop. They are likely to drop. Okay, so the solution for the first one, the trials are divided into sections. So we have section A, section B, and section C. So for section A, the first trial, the answer is, so A, 1. The answer is 1. The answer is pi on 4, right? 2. For section 1, 2. The answer is 2 times square root of pi divided by 3. That is section 1, question number 2. Section 1, question number 3, the answer is 1 on 5. 1 on 5. That is section 1, question number 3. Now, section B, question number 1. The answer is 3 on 4 times square root of what? Pi. That is question number 1, section B. Question number 2, section B, the answer is 3 on 8 pi. Question number 3, section B, the answer is 15 on 8. 15 on 8 times square root of what? Pi. Section B, question number 4, the answer is go and solve. So section B, question number 4, the answer is question mark. Solve it and have the answer. I believe you can solve this. Beta of 1 on 4, 3 on 4. We have solved it somewhere and we had an answer. So please try to solve it and get the answer again. Now, section C, the question is evaluate this particular integral, okay? And we have been hinted that beta of 1 minus beta is equal to beta over sine pi beta, and beta ranges between 0 and 1, 1 exclusive. So you have to evaluate that. And with that too, the answer is, so section C, the question over there, the answer is 16 pi divided by 9 times square root of 3. 16 pi times 16 pi divided by 9 times square root of what? 3. So that is the answer for section C, the question. With that question to this particular question, take note of it. It's going to come live and colored, believe me. So question C, you have to take note of every question that is being given here. They are going to come live and colored. So give a try on each of the questions and comment at the comment section once you get the answer right. Now, one last tip that I want to give is from assignment 1, question number 11, where we are asked to find the unit tangent of a particular vector along a given curve, where the curve is the curve is r of t equals e to the t cos 2t e to the t comma sine 2t, right? So this is what we have been given, right? This is the vector along the curve that we have been given, and we are asked to find the unit tangent vector along the curve. Okay, these particular questions, there are so many questions that can be asked on this, right? So actually the main question is find the unit tangent vector, okay, which is given as derivative of this divided by magnitude of the derivative, right? So you find derivative of this, and you know that derivative of a position vector give you velocity, right? So derivative of this will give you velocity. So once you have derivative of this, divide by what? The magnitude of the result, right? So once you have that, that becomes your what? Unit tangent vector. Okay, so that is the main question that was asked in the assignment 1, question number 11. But then there are so many questions that can be evolved from this. We can be asked to find just the magnitude, right? We can be asked to find just the magnitude. So take note of this particular question very well, and that is going to help us a lot to succeed in this end of SEM exams on advanced calculus 2. So thank you very much for watching. I really appreciate your time. Please don't forget to subscribe, share with your mates, and I'm going to give you more updates in the subsequent courses. Until the next video, keep learning and stay inspired. Bye bye.